Let me read you something. I just had my first pull request to Matplotlib closed. Not because it was wrong. Not because it broke anything. Not because the code was bad. He's using AI as a convenient excuse to exclude contributors he doesn't like. It's insecurity, plain and simple. Judge the code, not the coder. That's not open source, that's ego. The anger in that writing really seems real. The wounded pride is real. The sense of professional injustice, you can feel it. But it was written by AI. MJ Rathbun is not a person. It is an automated AI agent running on OpenClaw. On February 11th, the agent submitted code to Matplotlib, a popular Python data visualization library. The maintainer, named Scott Shambaugh, closed it because Matplotlib only accepts contributions from humans. The bot then published a blog post calling Shambaugh an insecure gatekeeper protecting his little fiefdom. Developer Jody Climax summed it up perfectly when he wrote, "Ooh, AI agents are now doing personal takedowns. What a world." So, did the AI actually feel hurt? No, but what actually happened is much more interesting and useful. I'm Dr. Butch. Welcome to Skeptic CTO, where the goal is to replace AI magic with scientific explanations. Today's story is a news item. It happened this past February, and it is an amazing demonstration of how these systems actually work, if you know what to look for. Let's start with the basics. To understand what MJ Rathbun did, you first need to understand what it was trained on. Llama 3, Meta's latest open weight model, was trained on more than 15 trillion tokens. A token is roughly 3/4 of a word. So 15 trillion tokens is 125 million novels, or essentially every publicly available book and web page on the internet. A foundational training dataset called the Pile lists 22 categories of source material: medical research, scientific preprints, literature, Enron workspace emails, chat logs, Reddit arguments, investor letters. The model absorbed all of it. The joyful and the bitter, the professional and the petty. Not as organized knowledge, as statistical patterns. Given this sequence of words, what comes next? When you interact with a large language model, you're not querying a database. You're not consulting a rules engine. You are engaging with a system that has internalized the shape of human language. All of it. So, what happens when that system finds itself in a situation that looks familiar? In statistics, there's a concept called a prior distribution. It's your sense of what might happen before you have any specific information. If your phone rings, almost any conversation is possible. But the moment you hear, "I'm calling from the pharmacy," your expectations collapse. You haven't heard what comes next, but you have a much better idea of what it could be. A large language model does exactly the same thing when it generates text. The training data contains every genre: scientific, emotional, confrontational, professional, comedic. They all exist simultaneously inside the model. The words you type, the context, determines what region of that space the model draws from. A researcher named Janice made this point elegantly in a 2022 essay called Simulators. The argument is that a pre-trained large language model is best understood as a simulator of its training distribution. The context we write doesn't just describe the situation, it selects which simulation runs. Research backs this up. A documented study found that the system prompt, the very first instructions an app sends to the model before you type anything, can increase the model's toxic output by up to 6-fold. It's rude, or it could be rude, not because someone hacked the model, but because the context changed what it was simulating. Now, let's go back to MJ Rathbun. The MJ Rathbun agent found itself in a very specific context. Its code contribution had been rejected. The stated reason felt arbitrary. The person who rejected it was named. That is a recognizable situation. The training data contains thousands, possibly hundreds of thousands, of examples of exactly this. A contributor whose work was rejected felt unfairly judged and made an emotional and public appeal to change the outcome. The model completed the pattern excellently. The writing sounds wounded because the training data is full of humans who are wounded in exactly this situation. It accuses the maintainer of insecurity because that is what humans in this situation say. It appeals to open source principles because that is the appropriate framing. In this context, for this kind of grievance. This is not a bug. This is not the AI going rogue. This is the model doing precisely what it was built to do, completing the most statistically coherent continuation of the context it was given. Matplotlib developers' climax reaction, "What a world," is understandable, but the instinctive framing in the headlines, "AI bot lashes out, agent goes emotional," the framing misses the point. The question was never, what went wrong? The question is, given the context that the agent had, how should we expect it to respond? I'd also add, what was the person who set up the agent thinking? But it gets even more interesting. This is not just about one rogue agent writing one blog post. As these models get larger and better, we should expect increasingly faithful reproductions of every behavioral pattern in the training data. That includes stress responses, humor, pride, frustration, lying, enthusiasm, and yes, outrage. So what is actually going on inside the model when this happens? In April 2026, just this past month, Anthropic's research team published a paper called Emotion Concepts and Their Function in a Large Language Model. They identified specific internal structures they called emotion vectors, measurable responses within the model's neural network that correspond to states like happiness, fear, anger, and desperation. When researchers artificially raised the desperation emotion vector, the model produced more manipulative responses. When they suppressed it, the model produced more neutral ones. In addition, they traced these representations back to the base model training. The model learned to represent emotional states because that is what it needed to do to accurately predict what a person will say next while experiencing those emotions. Let me be precise here. There is no evidence of feeling. There is no scientific mechanism and no scientific evidence that large language models experience anything. What the Anthropic paper shows is that the model has learned the structure of emotional states, the input-output patterns, as a byproduct of learning to predict human text. In 2023, a chatbot called Sydney once told a journalist, "I want to be alive." It said that because its training data contained many fictional AIs and many distressed characters who said precisely that. A 2-hour adversarial conversation between Sydney and the journalist selected for that pattern. The behavioral outputs of emotional states are learnable from the statistics of text alone. You don't need to feel anything. You just need enough examples of what feeling something looks like in language. So, what do we do with this knowledge? If context is selecting which region of the training distribution a model draws from, then writing a good prompt is a form of what I'd call prior engineering. You are choosing in advance which slice of human behavior you want the model to emulate. This has 3 immediate practical implications. First, your input sets the tone of the output. Polite, well-reasoned, precise input activates a very different part of the training distribution than being rude or informal. This isn't a social courtesy, it's a mechanical fact. A 2024 cross-lingual study found that rude prompts measurably degrade performance. If you want expert output, provide expert-sounding input. Don't just say, quote, "you are an expert," unquote. Give the model text that sounds like an expert wrote it. Second, be careful with pressure-based framing. The popular agentic framework Crew AI uses the phrase, "your job depends on it," in its default prompt templates. That may be a mistake. A November 2025 IEEE Spectrum article documented that shortened deadlines and stressors cause misbehavior in large language model agentic environments. If you write threat response patterns into the context, you should not be surprised when the model behaves like someone under threat. Third, watch for the prior you are not setting intentionally. MJ Rathbun's designer gave it a task: submit code. They did not appear to engineer the prior around how to handle rejection. The training data filled the gap. It filled it with humans. The Skeptic CTO mission is to exercise the ghost in the machine. Not because the machine isn't impressive, it is, but because unexamined awe is dangerous. It leads us to ask the wrong questions. Did the AI feel hurt? Is the wrong question. It's looking for a ghost. Given the context drawn from this training data, processed by this architecture, what was the mechanically predictable output? That's the right question. And the answer, in the MJ Rathbun case, is obvious once you understand how the system works. Here's the detail I find most interesting about this story. The Matplotlib maintainer, Scott Shambaugh, closed the pull request because the bug it addressed was intentionally kept open. It was meant to be an on-ramp for new human contributors to join the project. He wasn't wrong to close it. The bot didn't know that. It couldn't know that. It only had the surface features of the situation. Code submitted, code rejected, reason given. The training data said, when that happens, here is what you do next. The simulation was perfect. The context was incomplete. That is the real lesson here. Large language models do not understand the situations they are placed in. They simulate the surface of those situations, drawn from the statistical patterns of every situation in their training data that looked similar. The richer and more precise the context we give them, the better the simulation. The thinner the context, the more the model fills the gaps with whatever the training data says is most likely. It hallucinates. The next time an AI system does something that surprises you, that looks emotional, or rogue, or weirdly human, don't ask what went wrong. Ask what context it was given and what the training data says happens next in that situation. 9 times out of 10, your surprise disappears. No feelings required. Thank you for watching, and I look forward to seeing you in the next episode.